Our next speaker is Dr. John Cases. So John joined TAC in March of 2005. Prior to joining TAC, he served as the lead for climate, weather, and ocean HPC modeling at the Navy's Supercomputing Center. John has over 25 years of experience in HPC in public and private industries and currently serves as the director for HPC at TAC, where he leads the application performance efforts for TAC's 10,000 plus users. So today, John will be talking about the impact of SHARP on and adaptive routing on applications on Frontera. So John, please take it away.
Thank you, Ari. Let me see if I can.
So if people are wondering, I think the background that John has is probably of Stampede 2.
No, it's Frontera.
Frontera, yeah. So folks who have not been lucky enough to get into those machine rooms, those racks are really, really tall. So like about 10 feet or so.
It's like a canyon. Am I sharing? It's
not yet, John.
Okay. My mouse seems to be trapped. It doesn't want to. Am I sharing now? Okay.
So if you guys do get a chance, you should definitely try to visit TAC. So once you go in there, I think as John mentioned, this is called the canyon. Like you would have fans blowing in from both sides of your head. It's really fun to be in there. Yes, now we see it, John.
Okay, so let me go into display mode. Okay?
Yeah, perfect.
Okay, so the title's changed a little bit. It was supposed to be about applications, but I'll get into some reasons why I didn't quite make it to the applications. And when I say me, I mostly mean my staff. Okay, so just a little explanation of what Frontera is. 8008 Cascade Lake nodes, these are our general compute nodes. They're the workhorses. And everything I talk about today was run on the regular nodes. We also have a couple of subsystems for Frontera. One is 16 NVDIMM nodes. So NVDIMM is Intel's persistent memory technology. And so we've got that configured to support large memory users. And actually, eventually, we'd like to do some more MPI testing there because when you set up the NVDIMM, the DDR acts as cache, and it can impact your performance sometimes. The other subsystem we have are 90 GPU nodes, RTX nodes. And on that system, let me go to the next slide. So here we have 4 NVIDIA Quadra 5000 RTX cards per node, and these are single precision cards, not the double precision cards. So it's used mostly for machine learning and MD, and we have Mbappage 2 GDR available just on these nodes, not on the compute nodes. We don't want to confuse the users. And there you see the NVDIMM nodes. They're also a little special in that they're the only quad socket nodes that we have on Frontera. Okay, so just a quick mention about the fabric, the network. It's InfiniBand HDR. The switches are full HDR at 200 gigabits a second. To the nodes, it's a HDR 100. Basically, the 4-way connection splits into 2 ways for the nodes. And it's a fat tree topology. It's just a little bit of oversubscription. And basically, each rack has 2 top of rack switches. And we have 44 nodes for each half rack, so 88 nodes per rack. And the uplink is 200 gigabits per second. Okay, let's move into what we actually looked at. So the first thing we want to test is adaptive routing. And if you listened to Gilad yesterday, you heard a bit about Mellanox's adaptive routing technology. And what it does is it lets us balance the traffic by looking at which ports are busy and which aren't, which are available on the switch. And it also lets messaging recover if a link goes down without having to have the subnet manager reroute all of the links. And so it can be a great thing. Well, in our experience, it's a great thing that's taken us a while to get working. So over the past year, we've enabled it and disabled it many times. At some point, we thought it was working, and then we did some analysis and it wasn't, and we've gone back and forth with Mellanox. And in general, we just didn't have the right driver version, maybe the right kernel, or we had one library that was off. And it wasn't until about 3 months ago that we finally believed we got it enabled and it was working correctly. Well, after that happened, then the admin started noticing this funny problem with performance where the path between some nodes would have horrible performance. And they couldn't understand why, couldn't find an error message to correlate it to, started working with Mellanox. And what happened was in the last maintenance, or maybe the one before the last, Mellanox and our admins decided that adaptive routing was causing the problem. So just when we were getting ramped up to do a lot more testing with AR because we believed it worked, we had to turn it off because in it was starting this performance degradation issue that was hard to recover from. Basically, we had to reboot the top of rack switches, restart them, and so to fix the problem, we'd have to take half the rack down. So the admins decided, okay, we're going to turn it off until there's a fix. Luckily, we have a maintenance on September 1st, and I think Mellanox has a fix for us, and they're going to install it, and hopefully it'll work. If so, we'll resume testing after September 1st. So that's why I have no application data for AR right now. Even though we have some anecdotal data from before, we didn't do any real testing. We just poked at it a little and saw an improvement. We do have a few micro benchmarks. And so here's an all-gather benchmark on 512 nodes. And this is just one task per node. And you can see these are some pretty impressive improvements. The percentage improvement is up to 24, 25, almost 25%. And so since collectives are always a pain point for large codes, we think adaptive routing can really improve a couple of codes, one of which is Milk, maybe another is Chroma. They have a lot of collectives in them. And so we're looking forward to the ability to use AR and see what kind of performances we can get from our applications. And all the all-to-alls show a pretty impressive increase. Now, once it gets to the higher message size, it begins to drop off a bit. And also, this is something we need to test because at 256, we really want to scale out to 1024 and 2048 and see what it buys us there. Because we do know when we look at our networks, one of the biggest issues we see on our system isn't so much a lack of bandwidth. We usually have plenty of bandwidth. It's usually message congestion. And when we were looking at this before we had to disable, we saw that adaptive routing helped that a great bit. So once it's turned on, we'll continue to benchmark and we'll add in the applications. And so far, from once we got it configured to where we thought it was working, all the results seem to be good. We didn't find bad cases. Earlier on, when we had it configured, we never had it done quite right. And so sometimes we would run across issues where adaptive routing would impede performance. But up until this last one, in general, it helped performance. So if this follows through, we'll probably just turn it on by default for everyone. Okay, so the other thing we've been looking at is SHARP, Scalable Hierarchical Aggregation Reduction Protocol. And this is Mellanox technology where they're basically trying to remove the collective load to the switches so the aggregation can happen higher up in the tree and reduce your times. Also, this takes a lot of the weight off the processor and say in Babbage 2's library to calculate this on node or try to figure out what's the best way to do it. And we've just begun looking at this. Again, just like adaptive routing, over the past year, there were times we thought we had it enabled, it wasn't quite enabled. We needed a very specific set of libraries, OFED versions, and kernel versions, and actually, I think, firmware to make sure this worked. And it wasn't until a few months ago that this was enabled. And right now, we believe it's enabled, but we have so little experience with Sharp, there might be some tuning we need to do. And this is where I'd really like to thank DK and Hari and Momsy and all the Mvapage 2 folks for basically working with us on this and implementing it in Mvapage 2 and showing us how it can work to improve our performance. So right now, what I'm going to cover are a couple of benchmarks. We ran OSU All Reduce and OSU Barrier, and we've been working with them over the past, 3 weeks, 2 or 3 weeks to try to make sure everything's working. And basically, right up until today or yesterday, not everything was working, but Momsy put in a lot of time yesterday and fixed, I think, all of the issues that I found with task counts and tasks per node. And just this morning, I was able to run up to 1024 nodes and all my task counts and everything worked beautifully. The only issue we have left is we tried running with a few applications, and when we turned on the logging, we can't see any evidence that it was using Sharp. That doesn't mean it wasn't, but there's something hokey with the output. So we need to go back and make sure the applications are actually using Sharp when we turn it on. That's why I don't have any application results yet for Sharp. But that is the last little thing we have to do here. Okay, so let me explain a little bit about how we did this. This is how you turn Sharp on, NV2 enable Sharp. It's pretty easy. We ran the all reduce and the barrier benchmarks up to 4K message sizes. And basically, this is on the advice of the Mvapage 2 folks, because from their measurements, they see the advantage up until about 1K, and then basically their algorithms seem to do better at larger message sizes than Sharp. Although I'm not sure this is the version of Sharp that has the streaming optimizations that Gilad discussed yesterday, so this may change too. And basically what I'm going to show you are just plots for what I call speed up, time without divided by time with, for both all reduce and barrier. I don't have actual timings in these plots. It's easier just to show the comparisons. And I'm going to run from 4 nodes all the way up to 1024, and these are the results of 9 runs spread across 3 different sets of batch jobs, because I wanted to make sure I didn't get the same node set up every time. And that allows for variation across switch networks and how many switches I might have to hop to go between, say, 4 nodes, 16, or 1024 nodes. Okay, so here's at the low node counts, we see a little bit of improvement, not a tremendous amount, but it does always seem to be good until we get to the larger message sizes. This is encouraging because, to be honest, what I'd like to do for users, if we see that Sharp is always effective, we will just enable in our modules through the environment variables so that it's turned on for users, and only if they have a problem do we ask them to turn it off. But we need to do a little bit of testing to make sure that's valid. And so for the small node counts, we see improvement, and we see improvement pretty much up to 1024 bytes, and then it begins to drop off a little. And so then we go up to larger node count, you see better improvement, especially for the lower task counts per node. They really begin to separate. And this is probably just because once I add more tasks, the overhead I have locally on the node to consolidate the messages, that overhead is probably drowning out some of the advantage of the upstream Sharp improvements in the hardware. And so I guess that's to be expected. It does bother me a little bit that you see here on the 32 nodes, and you'll see this later, every once in a while, the sharp performance is actually worse than without, but there's a lot of variation, so I'm not sure how consistent this is. And so then when we get up to 64 nodes and 128 nodes, we see some really impressive improvements. If you're doing collectives with these small message sizes, um, I mean, that's a 7x improvement. Uh, I'm not sure how much in your overall code this will impact, right? Because these are very small messages, and so all reduces of small messages are probably a fairly small percentage of any application. But the the performance increase is quite impressive. Um, and then there's this constant trend of once you get to 56 tasks per node, it's not quite as good, although it's mostly better an improvement of one. And so now we're getting up to some pretty good node counts, 256, 512, and then in a second I'll show you 1024. And it's looking pretty good. So I would think we might set it up so we always enable sharp if you're using less than 56 tasks per node, which we can do in our job starter. And here, the speedups are still really impressive. I mean, if I'm not using 56 tasks per node and I'm below 1024 bytes, then I'm getting a speed up of over 3. Uh, if this is consistent and doesn't cause problems, we'll certainly enable this for the InVaprage 2 runs. And right now, only InVaprage 2 is using Sharp on our system. And so for 1024, yeah, you see we have a huge peak at 12x for a 32 byte size. Um, I'm not sure if that's an artifact, but again, everything looks good. And here, we might dip down to 1x, but we never really hurt our performance. Uh, so again, I think this is something we'll enable by default, especially for large node counts and fewer tasks per node. And what we see on our systems is most codes that go to large node counts above 128, they're usually running less than 56 tasks per node. We have a handful of users who will run 4,000 nodes with 56 tasks, but most users are running 14 or 28 with 2 or 4 threads, or 4 tasks with 14 threads per node. And if you're wondering why I have those strange task counts, it's because they're 56-way nodes, and so we run 1, 2, and 4, and then usually 14, 28, and 56 to simulate 1 thread, 2 threads, and 4 threads per task. So we also tested the barrier, and here everything looks good. It's always an improvement, and sometimes it's really quite an improvement. If you're running 1 task per node, Sharp can speed this up quite a bit. And so if you have a code that's very synchronous, very data synchronous, Sharp could really help you out. And as we move up to a higher number of node counts, we see the same thing. It's pretty consistent. The only time it seems to fall off is when we're running 56 tasks per node. And again, this is probably because the great improvement in the sharp hardware effect and the switches probably gets washed out by the collection, the barrier on the node. And so, and I have a note down there. I have one really bad case at 256 nodes, and it was really anomalous. It was just one instance of the run that was about 50 times worse than any other. So my guess is, yeah, I just hit a network event there. So far, I think, and Hari can correct me when I'm done, all they have implemented is all reduce and barrier, but I assume other collectives are coming. because this technology, for the first time I've seen, because Mellanox has been promising it for a while, it does really seem to improve collectives, and I'd like to see what we can do with some other collectives. So this performance variability we see at the full task count, and again, I'm not sure this is in Vapage 2 or Mellanox or Sharp. It could be our configuration. Our configuration for Sharp is that we don't have one. So basically, we're using whatever Mellanox considers to be the default, because we really don't know enough about it to know how to configure it. So working with the Vapage 2 group, maybe we can figure out if there are some knobs we need to tune for Sharp to improve this performance. And so, like I say, what I see at the full task count, I've never run Sharp or used it anywhere else. I'm not sure if that's a characteristic of how it works or if it's something we can tune away. And this thing about the applications, we just have to have a chance to run some more, and we'll continue to work with the Vapage 2 group to do it. And probably went fast, but so basically what we're going to do, once we get a chance, we turn AR back on, we're going to resume testing. I think it will show an immediate benefit to most applications. As long as we don't find it impacting performance, we'll probably enable it by default. We're going to work with Vapage 2 group to figure out how Sharp's working, and we'll add instructions to our training to show people how to enable it if we're not enabling it by default. And I'd just like to say, we really appreciate the work the Vapage 2 group has put into this and how they've worked with us. I mean, Mom Z was building RPMs for me last night to get this stuff working. So I do appreciate that a lot. And when we have problems on the system, they're very responsive. That's all I got.
Thank you, John, for the kind words. So there is one question on chat. Let me read it out to you. Thank you for your candid sharing of the issues using adaptive routing and Sharp. Do the performance issues when adaptive routing is enabled only manifest when running certain applications, but there are no performance issues when only running microbenchmarks?
So in our earlier attempts of adaptive routing, we had performance issues with different applications, but we never had it enabled quite right. Between my group, the HPC group, and the admins, reading the Mellanox documentation and then working with Mellanox, we really didn't get it configured right until about 3 months ago. And then this new problem that showed up, we never linked it to a specific application, and I don't think we ever figured out what triggered it. Mellanox was the one that determined that it was related to adaptive routing, because what our admins determined was that they got this performance degradation, but then if they enabled adaptive routing, it could work around the links that were bad, and so they would see better performance. But what Mellanox determined was that the adaptive routing being enabled caused some sort of error in the switch that reset something. The biggest problem was when this error happened, it wasn't logged anywhere. So we couldn't find that there was a performance issue until some user complained about their job running crazy slow. And then our admin, Tommy, I'm sure many of you know Tommy Minyard, he would basically take all the nodes and run one-to-one checks from node to nodes until he found the bad link. And then he would map it out. And that was the biggest issue, that it could happen. We didn't know what would trigger it. We didn't know how bad it would get. And then we had no way to easily fix it without taking half a rack down. So it got turned off, and hopefully Tommy will turn it back on next Tuesday.
Sure. To answer a couple of your questions that you had raised during your presentation, so the support for broadcast and reduce are on their way. So hopefully in the next few days, we'll have that implemented, and we'll get it out to you.
Mm-hmm.
And we would like to appreciate your efforts to, whenever we ask for nodes to run jobs, we appreciate the fact that you give us nodes on demand. So that really helps us out to debug issues, especially at these large scales, because there is no other place you can debug them.
No, and like the last time I gave Tommy a heads up, like, okay, if they break something, don't disable them right away. Try to talk to them. But no, I think you all have access now to large, and so you can run large. And we just ask, when you do, be careful. If you think you're breaking something, let us know.
Yeah.
Because yeah, they get testy, and I've done it before. They have to reboot 1024 nodes because I hung
So
up.
that's not fun. Yeah, we always have internal quality checks before we allow people to run at scale. We always tell them, hey guys, so we are on a credit-based scheme. So if you go to like really large scales and break everything, you lose credit and you're not getting it back.